Hello class, we're going to continue with part 3 of our Python list unit. And last time we talked about aliases and how aliases, we have to be careful if we have two variables that are referencing the same list item, that we can mutate the list using the B reference, the B variable reference, and A will also then see that same change because they're pointing to the same list. And I talked about how today we're going to see how we have to be careful about this. Now, normally we probably wouldn't even do code like this where we have A is equal to a list and then B is equal to A. This is a little bit atypical of how one would write code, because why wouldn't you just use A here? Why would you make up a new name for it here? But we're going to see a case right now where this aliasing does happen. And it happens when we pass inputs to, when we pass lists as input parameters to functions. And the thing is that we're only passing the reference to the list. We're not actually copying the entire list when we pass it to another function. And because the list, because the reference will be an alias, and because lists are mutable, any changes that occur to that list inside that function will be seen outside of that function as well. And that might be a little weird to understand just in words. So right now we're going to actually look at what I mean by that. All right, we have two functions here. I have a function that works, that changes a integer. I have a function that changes a list. Let's call each one and see what happens. The first one here, my variable is equal to 1. So I make an object 1 and my variable points to it. Then I'm going to call this function up here. My variable gets passed as the input parameter, and when that happens, this gets passed up there, and so val ends up getting a copy of my variable in the sense that they get a copy of the reference. They end up referencing the same object. So this is visually what happens. And so then when we say val is equal to 1000, what happens then? Well, we don't change the 1000 because Python integers are immutable. So what happens is a new object is made with the 1000, and then val gets updated to point to it. And so notice that my variable did not change. So when we exit the function and we return back, my variable still has the value 1. And we could see the kind of diagram of that up here. And we understood this in terms of what happened with functions and integers that are passed to it. But now let's look what happens when we pass a list instead. So in this case, my list is equal to 1, 2, 3. So let's make a list, and let's create a variable that points to that list. Now let's call the function here. And so in this case, my list gets copied to list, but when I say copy, I mean the reference gets copied. And so what happens is that this list variable here ends up referencing the same list that my list did, similar to this, right? My variable points to 1, val points to 1, my list points to this list, and list here points to this list. Same thing. But let's follow this next line here. List 0 changes to 1000. So let's follow that. List 0 changes this value. And lists are mutable, so I could change this element. And so what's happening here is an object with 1000 gets created. Element 0 now points to that. And so notice that in this case here, when we print out my list, it prints out 1000, 2, and 3 because my list actually, this list did get changed. And so notice here, this got changed to 1000. So you have to be careful here. Up here, 1 stayed to be 1. Even though up here val became 1000, my variable remained 1, but over here my list actually did change. So because list is an alias of my list, any changes to the alias changed my list as well. And we just have to be very careful of this. We have to understand this. This is the way it works when we pass lists to another function. Now, sometimes that's a desirable thing, this effect here. Sometimes it's not. And suppose you didn't want my list to change. What would we do? What we can do is that we can make a copy of the list. We can make what's called a clone. So how do we do that? The way we make a clone is by using that syntax in Python. So this is saying take this list here and make a copy of it. So let's visualize this. So my list is this 1, 2, 3. When I clone it, a copy of this list will be created. And clone here will now be a variable that points to that list. And so if I print out my list in clone, it's going to look identical, at least the printout of it, 1, 2, 3, 1, 2, 3. But if I print out is clone my list, and in this case, this is, we haven't seen that before. Is a special command in Python that says, are these two objects referencing the same thing? Are these two objects literally identical? Do these two variables point to the same object? And it says false because they actually point to two different objects. So again, just a clarification, is a special Python operator, and it indicates whether the two variables are referencing the same object or not. In this case, they are not referencing the same object. Okay, so now this time, let's call my function 2 with the clone instead. So now, if I call it with the clone, this clone will get kind of copied in here, the reference to it. So val will also point to this same object. And we end up changing val 0 over here. But notice, my list is not affected because my function received the clone and not my list. So if you want to be careful, you have to make a clone either before you call the function or inside the function. We can make the clone inside of it so it doesn't change the original input parameter. Okay, so do these problems. I'm just going to pause. Okay, let's continue. Now I'm going to actually kind of diagram and walk through this because these are, important to go through. So let's, I'm going to diagram it like this, where A points to this object. Then I call function F1 with the input A. So A gets copied, the reference, when I say A gets copied, I mean the reference of A gets copied to the list. So now list and A point to the same object over here. So that's what I mean by this list, the arrow to this object. Now look what happens right here. I'm making a clone of this list. So I'm going to make a brand new list right here, 1, 2, 3, which is different from this list 1, 2, 3. And now I'm going to change this pointer here to point to this cloned version instead. And so if the length of this list is bigger than 1, and yes it is, then remove item 0 basically, and then return the list. So item 0 is removed, and then we return that list, but it gets returned, but nothing, it's not used really. So the return value is almost, it just don't care. Now when I print A, what does A point to? Okay, A's here, and it references this list here. This list here did not change. Now let's look at this. F2 of A, so what happens here? So again, I'm calling F2, A, the reference gets copied to this variable. So now this list down here also points to this list up here, but in this case, I don't make an alias. Watch what happens. If the length of the list, and in this case, this list up here, the length is 3, it is bigger than 1, so remove the item at index 0. And so what happens is that this item right up there gets deleted. Now, notice I don't even have a return statement. It's not like I'm returning anything, but even still, when I print out A, let's look what A has. A has only elements 2 and 3 in it. So A got changed. Even though we didn't return the list, because we sent an alias of it over and we modified it inside of the function. Okay? All right, another change of gears. I'm going to talk about how do we iterate through lists. Basically, it's the same as with strings. We've learned how to iterate through the characters of a string, and now we could learn how to iterate through the elements of a list 3 different ways. First, we can iterate what I'm going to call by item or by element. And this is the simplest way of iterating through a list. Simply for every item in the list, print the item. So item gets 1, then item gets A, then item gets 3.14. The other way is by iterating by index. And what I mean by index is we're generating the numbers 0, 1, and 2. So in this case, we say for index in range of length of list. So basically, it's 0, 1, 2. Index gets 0, so we access list 0, then list 1, then list 2. So it's a little more typing, you can see here, and a little more extra here. This is, this is the easiest way, but sometimes we want to do it by index, and we'll talk about why and when. Last way is with a while loop. So we need to initialize, and when we use a while loop, we're going to be using the index method, but just with the while loop instead of a for loop. So we'll initialize index to 0. While the index number is less than the length of the list, then do something with that element. And then make sure to increment the index as well. Okay, so we saw each one of these 3 methods with strings, and we're just reapplying it in the exact same way with lists. So here's an example, and this shows the difference of when sometimes I want to do it with some constructs and when I want to do it a different way. Print out the even numbers in my list. In this case, I don't care where it is, I just care what it is. So for every item in the list, if that list item happens to be an even number, print out the item. Second case, print the position of all the numbers. In this case, you see the word position, and this is kind of a key thing that, oh yeah, I need to make sure I know where I am in my list. So for every index in the range of the length of my list, from 0 ... to 99, if the item in my list at that index equals 100, then print out a message saying I found the value 100 at a certain position. So certainly if you need position information to do your code work down here, you want to use the index way instead of the item way. Now, you could choose, you notice that I chose kind of more descriptive variable names. I didn't just say for I in list and for I in range. I could have just used a simple variable I for both of these, but I'm trying purposely to use variable names that are a little more descriptive, and so that you don't accidentally do the wrong thing with it. I see sometimes people trying to use this item here as an index value. So what you don't want to do is this, where inside the code you do something like list item. because item is not an index number. It's not a number from 0, 1, or 0, 1, 2, 3. It's one of the elements in the list, and so we don't want to do that. Okay, lastly, print the position of the first 100, meaning we don't need to keep on looping once we find the 100. So that means we should probably use a while loop because we want to stop looping. We don't want to loop, all the way through the list. So I'm going to set my position to 1. Position is going to be my answer. So I'll initialize it to -1, saying I have not found it yet. I'll set my index to 0 because I want to start searching it from item 0. And while I haven't reached the end of my list, that's what this is saying. And while I have not found the item, when pause is -1, it means it hasn't been found yet. But if I do happen to find the 100, if the item that is at this particular index is 100, if I found the first 100, then I'm going to say, well, the position I found it in is this value, and then of course continue incrementing my index. And so if I did find it, then I would break out here and end up printing out the position. All right, so do this. I'm going to pause, and then I'll just show the answers right now. All right, everybody, that's the third part today. We'll continue on next time with part 4. Have a good day, everybody.